ability. You want to have surveillance ability around your house. Okay. In my case, I need internal surveillance ability because my kids always come back to me and say, "But she said blah 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 blah. But he said blah blah blah. He touched my stuff blah blah blah. But she touched my stuff first." So, it would be nice if I have, internal surveillance capability. I can just replay the clip and see, who, broke whose Lego toy first. Okay? I don't think any thief is interested in my house. They will probably just trip over something, and I will end up, I lose money because they will sue me. Okay? So that is, but anyway, but you can think of, apartments, might want to install, or if you live in an apartment or a house, you might want to install, certain cameras outside of your house, to take a look, around your house without you having to kind of lift up your blinds to kind of take a peek outside. Okay? Well, how does that relate to what we're talking about?
Well, you can link those cameras up to the network, and then through the network you can access it by iPhone or some other digital device.
Yep, anything that has a browser. Okay, so he's exactly right. Each surveillance camera is also a web server. Okay, in other words, you can log in to a camera and just say, okay, display the stream at this point. So you will see in real time, what is happening. But each camera is also intelligent enough that you can set, hot zones. You can say, okay, this is the zone that I want to be motion sensitive. So if nothing happens in that zone, you can view the stream, but nothing is being recorded. Okay, there's no alarm, nothing is being recorded. But as soon as there's activity in that zone beyond a certain threshold, then the camera will say, I better start recording and maybe send an alarm. So the camera will actually start to record a video clip, right at that moment, and sometimes it will start like 5 seconds before the event because it can keep that much in the buffer, when it's doing the streaming thing. And then the camera can send you an email, can send your iPhone an email or SMS message and say that there's an event recorded. You can log back into the camera to look at the recorded clip, or your camera can upload that clip to another server. In other words, if a crook breaks into the house, look at the camera and go, I'm being recorded, and smack the camera into little pieces, that's not going to help. Because a lot of times the video is already uploaded to a computer that is off-site. Okay? So now, depending on how many of these cameras you want to install at your house, each one will also take up one IP address. Okay, are you guys getting the idea of how many things can now attach to the network? Lots and lots. So that's why I said, we may not have that much time before an average house or an average home will run out of the 254 possible node addresses of the 192.168 dot something address range. Okay, are you guys starting to see, how technology is moving quicker and quicker and quicker and quicker? The pace, is always going to increase in terms of technology. Anyway, so getting back to this point here, what I want to do is to specify the number of bits in an IP address that corresponds to the network address. So the question is, how do we specify which part of an IP address is the network address and which part is a node address? Okay, it is not fixed. It is not always 24 bits for the network address and 8 bits for the node address. It's not always 8 bits for the network address and the rest 24 bits for the node address. This is changing all the time. So this is why we use a net mask to indicate the portion of network address in a 32-bit IPv4 address. Okay? So imagine that you have an IP address, okay? An IP address is a 32-bit thing, right? So you have lots and lots of zeros and ones, okay? 1, 0, 1, 1, 0, 0, 1, 1, 0, and you spell out all 32 bits. The net mask is saying that if the net mask is a 1 corresponding to that position, that bit corresponds to a network address. If it is a 0 in the net mask, then that bit corresponds to a node address. Okay? So let me show you a simplified case. Okay? Let's assume that an IP address only has 8 bits. Okay, obviously that is not the case, but I don't want to have to use 32 bits. It takes up a lot of space and time to type. So we'll just assume that an IP address has 8 bits. A net mask of 1111000 means that the network address takes up the most significant 5 bits. The node address uses the least significant 3 bits. Okay, so now we just have to remember a network address is not 8 bits. With version 4, it is 32 bits. With version 6, it is 6 times 8, which is 48 bits. But the idea is the same. When you look at the net mask, whichever portion of the net mask that are ones correspond to the network address, and the rest correspond to the node address. Now, using this idea, it seems like we can actually have non-contiguous bits. In other words, these ones and zeros can scatter. But in practice, they do not. In practice, we always group the network address to the significant portion of the binary bit pattern, and the node address to the least significant portion of the binary number. Okay? Are we okay so far? Kind of? Okay. All right. So now we have the terminology necessary to describe a network. Okay? So a network has the following parameters. Okay? So we'll start with the net mask. The net mask is basically a format. Okay, it tells all the computers within the network, as well as computers outside of the network, which portion of the bit pattern specifies the network address, and which portion specifies the node address, just like what we have just talked about. So the net mask is definitely important because different networks can decide how much of the address is the network address. So that it is important to understand that part. We have the network address itself. Basically, this is our area code. Okay. And what else do you think we have to specify when we specify a network?
The node address?
The
node address?
Well, a node address belongs to a node within the network, but just for the network itself, these two are the mandatory requirements. In other words, whenever you have a network of computers, these two parameters must be specified. Okay? But then we have a whole bunch of optional parameters that are equally important. So we'll talk about this now. Optional would be the gateway. Okay? And we'll talk about the gateway. Remember Tom, Dick, and Harry in the apartment. Okay? Do you guys remember that story? Tom's computer is the one that was hooked up to the internet. Dick and Harry's computers are just connected to Tom's computer. Remember that? So when Tom's computer wants to go out to the internet, it doesn't have to go through anyone because it is connected to the DSL modem that goes out to the internet, and the rest is handled, quote unquote, by the cloud that we know as the internet. So Tom's computer does not have to go through a gateway because it is the gateway. How about Dick's computer? When Dick's computer wants to go out to the internet, what happens? Yep.
It sends a request to the computer to get to Tom's computer to get to the network.
But it needs to know who can get out to the network for it. So that's why you need to specify a gateway computer or gateway address inside a LAN, inside the local area network, or inside the subnet, so that when you specify an IP address that is not in the same subnet, then you know and say, the computer that I want to access is not within this subnet. How am I supposed to reach that computer that I want to get out to? So of all the computers, of all the nodes that are inside the subnet that I can talk to immediately, one of these better be configured as a router or a gateway. So I can approach the gateway and say, hey, Mr. Gateway, I know you can get out of this network and connect to other computers. Then you ask the gateway and say, okay, this is the IP address that I try to access. Can you try to see if you can reach that computer? Okay, that's the gateway, because the gateway allows all the other computers inside the subnet to go get out of the subnet. Okay, so I'll just write down here. A gateway allows nodes of a subnet to reach nodes that are outside of the subnet. Without a gateway inside your house, all the computers can only talk to other computers within the house, within the same subnet, which is not going to be very helpful because you cannot surf the web, you cannot go to Hulu, you cannot watch Netflix. There's nothing you can do other than accessing appliances that are within the same household. So that's why the gateway is very important, because it allows all the computers inside the subnet to access computers that are outside of the subnet. Are we okay so far with the terminology thing? In other words, if you want to go back to the phone number analogy, without a gateway, all you can do is to call numbers within the same area code. Okay? You cannot dial anything other than 916 blah 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 blah. If it is 925, around the Dublin area, guess what? You cannot reach those phones because you don't have a way to get out of the local area code. A gateway will allow that to happen. Any questions at this point? This is okay so far? Yep, go ahead.
I have here, all computer with a LAN have address that start with the same bit binary digit pattern.
That would be the network address.
Okay, and then the node address is the other part of an IP address besides the network address.
Yep. Yeah, a node address is like a phone number within a certain area code. Okay? So are we okay in terms of the concept of a gateway? Okay. Oh, by the way, when you go buy one of those router thing from Price, who is the gateway? That thing is the gateway. Okay, so there are many names to those things that you buy from Fry's. They would call those routers. They would call it a residential gateway. They would call it I think those two, firewall. Okay, so many times they will use some of these terms to describe those little appliances. But remember, a router is not a switch. Okay, it is not a hub. A switch cannot do what a router can do. A hub cannot do what a router can do, and I'll describe it a little bit later. Okay, there are other things that are optional. DHCP or dynamic IP address is another feature that is commonly found on most routers. Okay, when you have let's say 50 things to attach to a network, do you want to keep your own list of which computer, which TV, which appliance has which address? For the most part, you don't need to, right? If it's a printer, maybe. Okay, if it is a printer, you might want to fix the IP address so that you can configure every computer to access the printer by its IP address. But there are other ways to attach to a printer as well. But for the most part, you don't really need, this computer is going to have this address, this computer is going to have this address, this security camera is going to have this address, and so on and so on.